Okay guys, so this is problem number 208. Implement try, prefix try, and let's read it. A try, pronounced as try or prefix tree, is a tree data structure used to efficiently store and retrieve keys and data set of strings. There, there are various applications of this data structure, such as autocomplete and spell checker. What we need to do is we need to implement the try class. This function try will initialize the try object. This void inserts string word. This will insert the string word into the try. Boolean search string word will return true if the string word is in the try and return false otherwise. Boolean starts with string prefix returns true if there is a previously inserted string word that has prefix and false otherwise. Let's go through the example. So in the input we have try, insert, search. Search starts with insert and search. So here the try begins, and so in insertion I think we are inserting apple, searching for apple, and then app, and then starts with app, and then insert app and search. So here is how we are calling the class try, making an object and calling it. So object dot insert apples. First we are inserting it, then we are searching for the keyword apple. It has the try already consists of apple, so we are returning true. Next we are searching app. It doesn't have anything called app, so we are returning false. Next is starts with app. So apple does start with app, so that is why we are returning true. Then we are inserting app and then searching app, so it's returning true. So let's write what we all know already and what our goal is. We need to design a prefix tree try that can insert a word, check if the word exists, that is search, that is search, and also check if any word starts with a particular prefix, which will be in starts with. So each node in the tree will represent a character, and path from root to nodes will represent prefix of word. For example, if we are inserting apple and app, the root is at A, it starts with app, and then for app, it is the end of the word, but for apple it is apple and then end of the word. So a brute force approach that I can think of would be to maintain a list of all the inserted words. So whenever we call this function insert and word, we will just append the word to the list. Whenever we call search and then word, then we will check if the word exists in the list or not. And if we call starts with prefix, then we will iterate through all the words and check if any word which already exists starts with the prefix. So this is a brute force approach, but it won't work because this brute force won't work because for search it will go to through all the number of words and length of each word. So in list, search will check each of the word and character and starts with we check each word. So if n is like really large, if number of characters is very large and word length is really long, then this is not efficient. An optimal approach that I can think of would be to think like each node is a character. We will store children in a dictionary or hash map. So first let's create the init declaration, I think. So this would consist of children, which will map from tree to node. Keep it empty, hash map or dictionary like thing. So this will map from char to try node self dot end of word. This is gonna be false. However, this will be true if node represents the end of the word. This should actually go into class try node. So I'll make another class for it. Let me cut this or maybe copy this and put above it. So we can declare something called class try node. Then this definition will go inside it. However, for class try, what we can do is we can remove all these. Just keep self.root equal to, we'll call this classes object, like declare that. Okay. Now we need to create the insert function. This should insert the string word into the try. So I'm gonna do node equal to self.root, create a node, then for each character in word, if that character is not present in node.children, then node.children char try node. So here, let me write a few more comments. Here we are defining
It's 3 o'clock.
try node class, creating a dictionary, store child nodes. Here we are creating a boolean flag to indicate if node represents the end of the word. Define the main try class, try node class, like try class, not node. So here we are declaring a root node
I wasn't going to say it, but that's
I had to say
of
it.
the try, which is basically an empty node. Will not store any character itself. When we are creating def insert, this will insert a word into the try. We will start from the root node. Here we are iterating through each character in the word. If the character is not already a child of the current node, then we are creating a new try node for it. Otherwise, we will move the child node corresponding to the character. So this will be node equal to node dot children char, and after inserting all the characters, mark the last node as the end of the word. So we will then finally we can say node dot end of how is it declared end of word equal to true. Okay. Now coming to the search function. The search function will return true if the word is in the otherwise return false. So okay, node equal to self dot root. So we will start from the root node for character and word, traverse each character in the word. If the character is not found among the current node's children, the word does not exist. So we can say if char not in node dot children, then we will return false. If yes, then we will move to the next node. You can say node equal to node dot children char, similar to this line. Then after reaching the last character, check if it is marked as end of word. So we will return node end of word. Next, this starts with this will return true if any word in the try starts with the given prefix. So we start from the root node. For char and prefix, traverse each character in prefix. If the character is not found, no word with prefix exists. Char not and node dot children, return false. else we move to the next node. So we're gonna do node equal to node dot children char. Hi, I'm in library, college की library.
Hi, my name is James Irvin. IRWIN. I called your office about an hour ago.
क्लास 12 CS का पेपर है, उसमें अच्छा स्कोर कर। यार मुझे तो आइडिया नहीं है अभी लेटेस्ट कौन सा चैनल अच्छा है 12th के लिए। मेरे टाइम तो मैं एनसीईआरटी की बुक्स ही करती थी और एक आरडी शर्मा होता था। नो आई एम इन माई कॉलेज का लाइब्रेरी राइट नाउ।
About an hour ago, here in Fort Lee. And so the other day in your office, you
Yeah,
took my name
I'm a
and
student.
my number while I was and you said,
I'm in my final semester.
it's the way who does who schedules the consultations. Can you give me? I'm trying to. She said she was going to have her call me, and I've not heard back. I know you folks are busy, but I sort of. So the reason I'm calling now is to find out if that lady is available. Can you see if my call to your office about an hour ago?
I'm in my master's program. How much DSA is enough? I think
The woman
100 problems minimum.
took my name. Is it
I'm still on a 60, 70, I think.
refer you to in your office? Who she asked? I thought she said her name was Deb or something like. I'm not sure.
Okay, not in.
Okay, I can give you my birthday or something if that will. August, yes, August 27th, 1950. I was there about a year and a half ago.
Care not in what orchard.
Pictures of my clients. James is my first name. My last is
I like doing it in Python because it's kinda easy for me. I haven't like really worked with Java, JavaScript, DSA, so
Am I talking to Ruby? I'm trying to yeah, that's not true.
okay, let's think about time and space complexity. Domain. I have declared 2 classes and 3 functions and kind of implemented the try. From what I think, the time complexity of insert function of m or searching a word can be of n or O of m2, as we are iterating once starts with a particular prefix of, so that's gonna be the prefix O of P. Then for space
Hi,
complexity,
Monica. My name is James IRWIN, and I was in your office about a year, and I'm guesstimating
worst
about a
case
week,
O of N,
and Dr. French gave me some eye exams, and
where
Dr. Karen also looked at my eyes. And the reason I called
number
you
of words,
was, I don't know, I think I'm supposed to be, I don't know if you remember the
length of
name.
word.
I know you folks see a lot of patients. Um, hanging in there. So now,
Let me try and
I,
see if it's
you
running
know, so
successfully or
Dr.
not.
French, and more than Dr. Karen, but Dr. French in your office told me I need to get a tropium surgery on my eyelids, my lower, because they push out. So your office referred me to Dr. Gerber. So what happened is I didn't have a lot of money last year
I'm just getting started.
for the
Uh,
tropium surgery. So I put it off.
so
But what's happened
in my
is,
master's
in the
program, I had
meantime,
this course
I
called
went for
Algo
my
and
glasses prescription 2 weeks ago to
data
Walmart,
structure.
and
So
my
वहाँ से
eye
basics I
doctor
did,
there
and then geeks
said,
for geeks.
James, you need the tropium surgery, kind of like ASAP. You know, she said, she hinted, and so they referred me to Dr. Gerber here in Fort Wayne, as your office did. So I called Dr. Gerber like the next day. He is not available to even see me for the eye surgery for his exam until June. And then I don't want to put it off. And I'm also going to possibly move from Portland in the summer. So,
Okay.
so the other doctor Walmart referred me to is Dr. Eric Purdy, Purdy. The only issue I'm having is Dr. Purdy does not specialize in ectropion surgery. I'm concerned. So I went to Google reviews, and there aren't that many on Dr. Purdy. And one of them, there was only 5, and one of the 5 is not good.
I'm from Purdue University, Fort Wayne.
I have personally, because of that, and also because Dr. Purdy does not specialize in ectropion type of eye surgery. I just, at the gut level, would prefer to go to Dr. Gerber. So I'm wondering if you, I know you folks are busy again, but is there any chance you could just ask Dr. French if he thinks it's probably likely better to wait? I don't think I can. My sense is if I wait until June for Dr. Gerber's exam, then it's going to be 2 or 3 more months before Dr. Gerber could do it. Do you think, what would be Dr. French's opinion? Okay.
Okay, let's move on to the next question. So,
Yes. For Dr. Gerber, yes, I did. I asked her that. But the people at Walmart. So thank you for this information. So you seem to be suggesting, if I'm hearing you right, that I should call Dr. Gerber's office and be asked to put on a waiting list. In other words, what I'm taking from it is don't ask Walmart to do it, I should do it. I should be more assertive. Is that what you're saying?
So this question is 211 design, add and search words data structure. What we want to do is we want to design a data structure that supports adding new words and finding if the string matches any previously added string. So we have a
Could I
class
ask
called
you
word
what is okay
dictionary,
to ask
and
to
this function
refer me
called
to
word
the
dictionary will
document?
initialize the object. This definition of void add word word will add the word to the data structure, and it can be matched
I
later.
just need to.
The boolean function search word will return
I'm
true
sorry, I don't mean to
if
put you in the
there
spot,
is any
but
string in
I'm
the
just
data
thinking.
structure that
I
matches
know it's
word
a
or
distance,
false
but I
otherwise.
had my cataract surgery done
So word
at
may
Kellogg
contain
Eye
dots where
Center
dots can be
in Ann Arbor,
matched with any
and
letter.
something's telling me I should just go back there.
So input is word dictionary, add word, add word, add word, search, 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 and search. So first this is empty word dictionary, then we are adding the word bad,
Oh, go ahead, I'm
dad,
sorry, I didn't mean to.
mad,
Do,
then
oh, okay.
uh,
Do,
we'll
does that
search for
office
pad, but this will return
sometimes
false
alert
because there
some
is no pad
operations
already
to
in this.
Kellogg
Then
Eye
we'll search
Center
for
in
bad.
Ann
So
Arbor?
this will return true
Oh,
because we have
okay,
bad in it.
okay.
And then
I just
search
feel more
these two as
comfortable.
well.
I'm sorry, I don't mean to put you in the spot. I just, my eyes are so, you know what I mean? And I live by myself, and I'm a single man, and I just feel, I think I would prefer going to someone who specializes in this type of treatment. Making sense?
I think it's gonna be great if you could balance both, like in a week or in a month. Make few development projects, learn web development, and then also study for DSA. All the best. Okay, so
Okay,
let's
okay.
write what all
You
we
have
know.
been so helpful, Monica. I love your office. I really do. I love all the people that waited on me when I was a patient. And you've been, pardon? I did.
We need
I
a
did.
data structure
Thanks a
that can
lot,
store
Monica.
words
I really
dynamically.
appreciate
So
it.
we will have the
Yes.
function add word for
You
it.
too. Bye-bye.
We need another thing which can store, actually search for words. Search string may contain dot. So this dot can basically match any single character. A brute force approach that I can think of would be storing all the words in the list. This function called add word will append the word to the list. Another function called search word can basically iterate through this search word can iterate through all the words and then check or match character by character. But this brute force will be too slow for many queries or inputs and will not work for small data sets. So an optimal approach will be would be to use something called try, just like the previous problem, because if we want to use a try for search function, this will try all the possible children recursively, which is like depth first search. If a character is normal, we will follow that path and try.
When she gave me my prescription for glasses, she said
So this is like better and efficient word lookup.
and Dr. Gerber is one of the doctors she referred me
Let's
to.
create
I was
a
wondering if I could
try
schedule
node
an
structure
appointment,
first.
or do I need to go
So
back
we
to
will
him?
create
I kind of would prefer Dr. Gerber rather than
try
the
node
other doctor they
structure.
had mentioned. I like Dr. I'm sorry.
Class try node, and then this will create a definition. So this is gonna be init self, and then we'll create a dictionary,
However,
store child
I
nodes,
might, I'm wondering
self.children,
if I could be put on a wait list for Dr. Gerber. Is that possible?
self dot. So this is something called, this will return true if the node represents
I,
end of the
I'm
word.
sorry, I didn't hear. I'm on my cell phone now, and it's an old cell phone, and I didn't hear everything you first said. You said you had me, I didn't catch it all, I'm sorry. You said, not with Dr. Gerber, I'm sorry. Oh, oh, I'm sorry, I misunderstood. Does Dr. Gerber, um, specialize in eyelids too? Okay, I'm sorry. I totally misunderstood. I'm sorry. Can you send me an email or has your office already done that about the thing?
So let's go to class word dictionary.
Okay,
In this class word dictionary, we want to
okay, okay,
initialize root.
okay.
Try. So we're gonna do self dot root to try node.
Um, I didn't know. This whole thing has gotten because of
Actually, this should
I'll
go
take
in
it
here.
turn.
Next, in this add word, this will add a word to the data structure. So we're gonna do node dot first declare the root. Start from root for Karen word. If char not an node dot children.
Do you think, is there any way for me to look at your schedule? If I put this appointment with Dr. Gerber and see him in March, that would be time to still schedule between March 10th and there would be time. Okay. 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 Okay, just a second, please. I'm gonna reach for my wallet.
I'm just solving Leetcode problems. Okay. I'll add a few more comments.
And both now I'm trying to find
So here key would be character from A to Z, and value would be next character.
No, I didn't agree. I'm pretty sure this is right. Can you tell when you put it? See the Social Security where I have my Medicare A and B. They changed my card years ago, several years ago, to PF9 F is in Frank 7.
We use a trie prefix tree where each node represents a character. Next we have this add word. This will add the word to the data structure. Start from the root node. We will then iterate through each character of the word. So if the character is not already a child of the current node, then we will create a new node, create a new trie node for this character. Otherwise, we will move to the child node, which is corresponding to the current character. So we're going to do node equal to node dot children
So I moved back here to
cat.
And so did Walmart give you that address and say,
So after inserting all the characters, we
oh,
will
thank you for telling me.
mark the last node
I need to go
as
and
end of the word.
and-
Node dot end of word will become true then.
Yes. Yes.
This is programming, computer science, and then Python programming. And what I am doing is Leetcode.
Hi, I was just speaking with a guy doctor's office here before in Dr. Durfee, the doctor's office.
I'm from, I was born in Wardha, but I'm from Bhilai, Chhattisgarh. And then right now I'm in United States in a place called Fort Wayne. Okay, so let's define the search function. So we'll return true if any word in the data structure matches the search word. We'll create another function called dfs. The input will be a try node and an integer I, which will return a boolean.
Hi, my name is James Grogan. IRWINIR. Just spoke with Dr. Durfee's office. Dr. Durfee, I got you here.
So the base case for us will be if we have reached the end of the word, I don't got the length of word.
The question I remember is, so because my appointment is for March 10th, and my lease here in my apartment in February ends in late June, I'm just calling your office to find out if, so, for example, if I keep this appointment and say Dr. Bridget on March 10th, would there be enough time to schedule between then and June for Dr. Burkett to actually do the improvement surgery? Um, the reason is I'm saying my lease, my apartment lease only expires in June, and I'm like 99% sure I'll be moving away from it. So, if you could please call me back, then I also is not going to be iPhone. The appointment is for March 10th, and my number is 620-841-1653. Please hold on. Thank you, Chief. Oh.
Next we will be, so if we have reached the end of the word, this will be our base case. We will return true only if current node is marked as the end of the word. So we will return node dot end of word. Also need to check for wildcard. Just dot if character equal to dot. This is wildcard. Match any letter. So for child in node, dot children, like we're checking in all children and checking its value. We will then use recursion to search for rest of the words.
My name is James and I am living my best family people in front of her to see me for evaluation and voting possible surgery.
Okay, recursion. So we'll call this again.
Something has come up. My phone number is 630-841-1653. I tried to call the office. This is Monday afternoon. They wasn't able to get through.
This takes node, and then I integer.
I need to cancel it. Then I changed
Will return true. I think a good place to start will be basics of machine learning or taking a Coursera course. There is another website called deeplearning.ai which has like really trendy short courses. I'll write down in chat for you. Check this out. Otherwise, if any path does not return true, then we have to return false. So let's go out of the loop. Else if character is amongst children, continue DFS child. We'll call the DFS function again, but for children node. return false. We need to start our depth first search from root.
Hi, my name is James Wilson. I am WLN, and so I was in your office. There's a glasses prescription, and your office referred me to some surgery to either Dr. Purdy or Dr. Clover, and made an appointment for me with Dr. Purdy for this Friday, the 14th. Can you please cancel that appointment? I tried. Is there some way you could do it either on your computer? Because I tried to call his office just now, and at his office phone, and Dr. Williams, and I didn't get the real person, and I just want to make sure that this appointment is canceled. I sort of changed my mind. Yes, for this Friday.
So the definition, I need to align this. So start DFS from root node and index 0 of the word. So this is going to be return DFS self.root, 0. This is gonna be car word. Okay, I'll try and submit this. First, let me think about time and space complexity. Think for time complexity, we have this one function called add a word, and we are traversing through the array and adding each word. So this is gonna be O of m searching a word, which is basically search word function. Then this is gonna be O of, as there are 26 alphabets, so maybe O of 26 or O of 1, not sure on that. And then space complexity will be here. I think M will be length of word. And space complexity can be O of n multiplied by M, where M is length of word and N is average word length. And we see and try submitting this if it's working or not. says wrong answer. Null, 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 null. Expected null, null. False, true, true. So I'm getting this wrong. Where is the error? I'm starting the if loop. Here indentation error. I basically put it under if block, so let me try and fix this. I used recursion. This loop seems okay. Did I make a mistake? Oh, wait. Yeah, this is. Damn, these loops. First, I'm creating a DFS, then I'm targeting the base case. I'll return true only if current node is marked as the end of the board. So as we are traversing, I'm checking each character. I'm also checking for wildcard, which is the dot symbol, and this wildcard can match any letter which is used in search operation. So for any root child node and all the children values, I'm trying to use recursion. So if any path returns truth, our search succeeds, otherwise there is no matching path found. And so this is if we have a wildcard. If we don't have a wildcard and it's a normal character, and then we'll check the children nodes, we'll apply depth first search on that child. If there is no path, then word does not match. Okay. $59. think I've already used the indentation. Oh yeah, here. I got the error now. Such a silly mistake. Should work now. Submit it. Yeah, it's kind of slow. Exceeds limit. I have a Mac already. I mean, what could be better than this? Okay. Next question.
It's 4 o'clock.
Which laptop would you recommend for streaming? Like, I'm totally new to this YouTube thing. So, yeah. मुझसे बेसिकली ऐसे सॉल्व नहीं हो रहा, प्रैक्टिस करो भाई. तो मुझसे भी नहीं होता, बट लगे रहना पड़ता है. तुम्हें कोर्स में तो होगा ही, अगर तुम कंप्यूटर साइंस से हो तो आई एम श्योर कॉलेज में पढ़ाएंगे. I'm a big fan of MacBooks. I don't do any gaming as of now. Going for a coffee break.
Have scanners on the print too.
I was gonna say, I'm probably.
No, some actually a lot. This is for you have to wait a couple seconds. Your laptop didn't have it. That isn't a leash. Okay. Simple.
Rated like top 50. I think she won like 4 awards.
Pretty close.
I don't know.
What's up? Come on. How are you? I'm good.
Coffee. Okay, time for another problem. This is 212 word search 2. So we are given an M by N board and it's full of characters and a list of string words. What we want to do is we want to return all the words on the board. Each each word must be constructed from letters of sequentially adjacent cell, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once in a word. So input is board letters O, A, A-N, E, T, A, E, I, H, K, R, and I, F, L, V. Our words are which word? I think this is just like a scribble problem. Like if you've played scribble ever, so we need to arrange words. So words could that can be formed are oath, P. I don't see P that can be formed. What about eat? I don't think eat can also be formed. Rain. Okay. The output would be eat and oath, because this is the combo that can be formed from the given alphabets. Next is board consisting of A, B, C, D, and the words are A, B, C, B, which clearly cannot be found because there are not B's. So let's write down what we know already. We have a 2D board, letters, and a list of words. Our goal is to find all words from the list that exists in the board. The rules are words are constructed from adjacent cells, which can be horizontal or vertical. Next rule is each cell can be used only once per word. This definition is fine. Words or input is board and a list of words. So yes, I'm doing DSA in Python. I'm not in my office. I'm in my library. Okay. What next? A brute force approach that I can think of would be for each word in words, we can do depth first search on the board to check if it exists, if a particular word exists or not. But with this, W can be the number of words, M cross N will be size of board, and L will be word length. So this is very huge for large inputs and is not feasible. An optimal approach would be to build a trie So for each cell in the board, we can do DFS. Mm. Optimal approach should be to build a tree. So for each cell in the board, we will do DFS. We will check if current path is a prefix. If not tired, let's try. If current path is a prefix, then we add it to the result. We mark cell as visited. Let's create a class Trie node. We'll define use a dictionary or hash map to store all the children nodes where key would be, or character value will be try node. So I'll name it children, self.children, then a hash map. If this node marks the end of word, we will store it. So self.word equal to none. This will help us find all the words from a given list that exist in the board. First step will be to build a trie with all the words. So we'll make root, then try node for word and words. Start with root for each character and word. If character is not present in node.children, we'll create a node for it. यार मुझे भी पहले ऐसे ही लगता था कुछ समझ नहीं आता था कि ऐसे जब स्टार्ट किया, बट मैंने कोर्स लिया कॉलेज में एल्गोरिथम्स का तो धीरे धीरे क्लियर होने लगा। मतलब जब ऐसे वीकली स्केड्यूल बनाते हो ना पढ़ने का, आसान हो जाता है। और हाँ, गीक्स फॉर गीक्स या कोई प्रोफेसर या मेंटर होगा तो वो समझाने में हेल्प कर सकता है। Get the number of rows and columns. Make a array called result to store all the words found on the board. store mode from given set. So create a function called dfs, which will take a row and a column. यार अभी तो मैं अभी हाफ वे भी पहुंची नहीं, मतलब मैंने अभी तक कंप्लीट नहीं किया है. Parent will be current try node. So I'll declare a variable called char, which will access boards, row, and column. The node will be parent.children. We'll do optional optimization. Remove the leaf nodes and try. So if not node.children will pop the element.
It's 5 o'clock.
Okay, so this is problem 17, letter combinations of a phone number. So let's read it. Given a string containing digits from 2 to 9 inclusive, return all the possible letter combinations that the number could represent. Return the answer in any order. A mapping from digits to letter, just like the telephone number is given below. Note that one does not map to any letters. So here we have a keypad of a telephone number, and we can see that each number is associated to specific specific letters or alphabets. So for example, 2 is associated to the alphabets A, B and C. What we want to do is, if we are given 2 digits, we want to find all the combinations of the 2 word letters that could be formed from them. So here the digit is 2 and 3. So we can make a combination of A and D, then A and E, A and F, and then another could be B and D, B and E, and B and F. The third could be C, D, C, E, and C, F. So this is something that we want to return. Next example is, suppose if we take up the digit 2, so our output would be A, B and C itself. So let's write what all we know. We are given a string of digits starting from 2 to 9. Each digit maps to letters like on a phone keypad. For example, 2 belongs to ABC, 3 belongs to DEF, and 4 belongs to GHI. Our goal is to return all possible letter combination represented by these digits. So one approach could be to perform depth first search, or backtracking. First, I think we need to create a hash map consisting of a mapping between the numbers and the alphabets associated to it. So we will map digits to letters in a dictionary. We will map digits to letters in a dictionary. We will start our depth first search, that is DFS, at index 0 of digit string. Note that 0 does not contain, 1 and 0 do not like map to any letter in the phone pad. So at each step we will go through all the letters in a particular number which is mapped to the current digit, and then we will append the letter to a temporary combination and maybe use recursion. Okay, let me write that down. We will map append the letter. No, at each step we will iterate over all the letters. Mapped to a particular digit. Maybe use recursion after that. Okay, so let me write the library. From typing import list. Here we have a class which consists of a definition called letter combination, which takes in the number of digits in the form of a list. So first we'll go with the edge case, which is if the input is empty, we will return an empty list. Let's make a hash map or a dictionary to map digits to letters. So I'll name it phone underscore map, and I'll add the letters and digits in it. So 2 has A, B, C. 3 has D, E, F. 4 has G, H, I. 5 has J, K, L. 6 has M, N, O. 7 has year for alphabets, so P, Q, R, S. 8 has T, U, V. 9 has W, X, Y, Z. So this is the mapping that I could think of right now. So first we will create an array to store all the combinations that we get from particular 2 digits. So I'll make it result. Now we can create a DFS function. Create a DFS function. This seems like a repetitive pattern in all the questions. Like we are supposed to create a depth first search function all by itself. So I'm gonna write def DFS, which takes in something called integer index and a path which is string. So here the index will be the current position in the digit string, and path will be current combination of letters. What's our base case? So for our base case, if our path length equal to digit length, we have a complete combination. So if index equal to length of digits, then we will append the path and return. So this is 2, 3. Current position is 2. If it is 2 letter, we have a path, I think. So suppose we have digits 2, 3, and 2 is at index 0, 3 is at index 1. So for something in index 0, which is 2, we have letters A, B, and C. First we will choose A, and then choose 3 letters D, E, F and append it. So choose A and append D, E, F to it. Then choose B and append D, E, F to it. Choose C and then append D, E, F to it. And final result will be concatenation of all 3 combos. Yeah. So if our path length is digit length, we have a complete combination. Next we can get letters. We can extract letters mapped to the current digit. So I'll declare this current digit. So give me the digits index. Letters will be phone map current digit. For letter and letters, we will first extract and then append the letter to the current path and move to the next digit. Recursion call explores further letters from the remaining digits. So we can say DFS. We will move the index, so index +1, path plus letter. we are going to the next digit and continuing to build our current combination by adding current letter to the path. So we are adding path and then letter and iteratively moving to the next index as well. This is backtracking, I think. So we want to go to the root now and we will create or start the depth first search from the first digit with an empty path. So I'm gonna say DFS start from the first index or the first digit and there is no path. So this can be like this. Next we return all the combinations found. So we will return the result. So what I can think is first we handle the edge case here. Edge case is basically if the digits are empty or hash map is empty, we will return an empty list because there are no combinations that could be possible. Next is making a phone mapping, that is mapping all the digits to the corresponding alphabets which are available. The digits from 2 to 6 are like mapped to 3 letter alphabets, whereas 7, 8, 9 are like specifically 7 and 9 are mapped to 4 alphabets at once. Next, we are creating a DFS function which keeps track of the index, which is the digit we are currently processing, and a path which keeps track of the current combination of letters. So if this is the base case, so if the length of our path is equal to length of digits, which this means that we have chosen one letter for each digit, and this is a complete combination. We will append this combination to each of the other numbers letters one by one. So for each letter mapped to the current digit, we will append it to the next path and again we'll call the DFS. So we will be exploring all the possible combinations. In the end, we are starting our DFS from root node. As far as the time complexity goes, if our n is the number of digits, each digit maps to 3, 4 letters. So our maximum combination will be 3 to the power n minus m or 4 to the power m, where m can be digit which has 4 letters, that is 7 or 9. So, and for the space complexity, as we are using recursion, so recursion stack has O of n but can store result list of all combinations up to 4 to the power n numbers. So I'll try and submit this. Okay, so this problem next is number 77 called combinations. We are given two integers n and k, and our goal is to return all possible combinations of k numbers chosen from range 1 to n. and we may return answer in any order. So for example, n is 4, which means the numbers can be 1, 2, 3, 4, and k is 2. So we can have numbers of combinations of 2. So from 4 we choose 2. So I think that is 4c2, which gives us an output of 6 combination. Combinations are unordered, that is 1, 2 and 2, 1 are considered to be same combination. So yeah, let's write down what all we know. We are given integers n and k. Our goal is to return all possible combinations of k numbers chosen from 1 to n. Order does not matter. So an approach could be using DFS or backtracking. We can build combinations incrementally. We can start from the first number 1 and then add numbers one by one to a temporary combination. As soon as the combination length is k, we will append it to the result. We can then backtrack by removing the last number to explore other possibilities. To avoid confusion, when choosing numbers, we can start from current number plus 1 to avoid duplicates and maintain increasing order. So I'll write a library first from typing import list, and then this combine takes in two integers n and k, which is like nc2 or nck, the form of a list. So this function will return all the possible combinations of k numbers from range 1 to n. So we will store the result temporarily in not temporarily, like store the final result in an array. So I'll write to store all valid combinations. Next, create a backtracking or DFS function. So I'm gonna write def backtrack, which will take a start integer and a path integer, path in the form of list. So this start will be a form integer, which will the number to start from for this step. The next will be path, which will be in the form of list of integer. This will be current combination being built. The base case would be if the current path is equal to k. You can say that we have a complete combination already. So I can write if length of path equal to k, then we can append to the list result dot append path dot copy. So we will append a copy of the current combination. Once this is done, we can return none. At least now we know that we have a complete combination of letters. Now what we want to do is we want to explore the numbers from start to the number n. So we can write for num in range of start comma n plus 1, like not the initial digit but next to the initial number. We will append this number to path, choose the current number. Then we can call this backtrack function again and use recursion with the next number. After recursion, we need to pop the number as well from the path that we just created. Remove the last number to try next. Start backtracking from number 1 with an empty path. Can do backtrack 1 comma this and then return result. So first, if we have n equal to 4 and k equal to 2, initially our path is an empty list So first we will choose the number 1. So path will consist, we will append 1 to the path. Next we will choose the number 2, and now path becomes list 1 comma 2, and we'll append it to the result. Next we will choose 3 but pop 2, so this will become 1 3. Next we choose 1 4 like number 4 but pop 3, so this will become 4. Next we will choose path 2, so this will become 2 comma 3 and 2 comma 4. Next we'll choose 3, so this will become 3 4. And there are like NC2 NCK choices, that is 6 total combinations. As far as the exit condition goes, as soon as our last digit becomes 4, so length is less than k, so we should stop. Now when we think about time and space complexity, I think there are NCK options to choose from, which is like C comma N comma K combinations. It will become O C N comma K multiplied by K. And this will be same for space complexity as well, I think. Submitted. Okay, so this is problem 46 called permutations. We are given an array nums of distinct integers. Our goal is to return all the possible permutations possible, and we can return the answer in any order. So, for example, if the input array is 1, 2, 3, the output can be 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Basically, all the permutations possible. And yeah, if the input is 0 and 1, then output would be only 2. From initial glance, what I can think of is it's 2 to the power n. Is it 2 to the power n? Or no, actually, no. there's nothing like that. Okay, so we are given an array nums of distinct integers. Our goal is to return all possible permutations of these integers. So in combinations order doesn't matter, but in permutations order matters. So order matters in permutations, unlike combinations. We can use DFS or backtracking to keep a current path representing the permutation being built. Each step we will iterate over all numbers in nums. So we will first iterate through all the numbers in nums array. If a number is not already in the current path, we will add the number to our path and perform a recursion. When our path length becomes equal to the length of nums, we will make a copy and append it to the result.
You mean this one?
We can then backtrack by removing the last number, which I think we will be popping the last number to make sure it doesn't repeat again, to explore other possibilities. So this def permute takes in a nums list of numbers, and we can write the library from typing we will import list. This will return all the possible permutations of given list of distinct integers. So let's create an array called result, which will store all the permutation. We can make a backtracking or DFS function. I'm gonna name it as def backtrack, which will take in a path in the form of a list integer. So here path is current permutation being built. The base case will be if the current path has all numbers, we can say it's a complete permutation. So for this we can check if length of path equal to length of our nums. Then we can append a copy of it. As I mentioned in the above comments, result append path.copy. So we will append a copy to the result. This will return none. You can also try adding each number that is not already in the path. So first we will iterate through all the numbers for num in nums. If the number exists in path, then we can continue. This means skipping numbers already used in current permutation. Otherwise, we can just append the number to the path. And this will be choosing the number and appending it. Next, we'll call backtrack function and send path to it. Use recursion to build permutation further. And as I mentioned above, we need to pop the last element to make sure all others are considered as well. So we'll do path dot pop backtrack and remove last number to try next. In the end, we will start backtracking with an empty path. So backtrack, then we'll return our result. So how does DFS explore? Suppose we have nums and it has digits 1, 2, 3 in it. So initially the path will be empty list. Then we will choose the digit 1 and we will append 1 to path. So the list will just now just consists of 1. Next we will choose digit 2 and we will append 2 to the existing list. So now the path list consists of number 1 and 2 in it. Next we will choose digit 3 and we will now backtrack 1 and then choose like pop 2 and choose 1 and 3. So then we will choose 2 and we'll append 1, 3, 2. So we will be choosing 1, 2, 3, then 1, 3, 2, then 2, 1, 3, 2, 3, 1, and things like that. So here our time complexity, as it is a permutation, so I think it's gonna be O of n factorial permutation because each of length n is copied to the result. As far as space complexity goes, as we are doing recursion and backtracking, it's gonna be O of n recursion stack for recursion stack and O of n factorial multiplied by n for result stack. Let's try and submit this. Okay, so this is problem number 39 called combination sum. We are given an array of distinct integers called candidates and a target integer called target. Our goal is to return a list of all unique combination of candidates where the chosen numbers sum to target. We can return combinations in any order, and the same number may be chosen from candidates an unlimited number of times. We can say two combinations are unique if the frequency of at least one of chosen numbers is different. So, for example, the input is candidate list. Candidate is consisting of number 2367, and our target number is 7. So our output is gonna be 2, 2, 3, and then 7 separately. Because 2 and 3 are candidates, and the sum of 2 plus 2 plus 3 gives us 7. And here, like 2 can be used multiple times. So either 7 can be just one candidate, or sum of 2, 2, and 3 can be one candidate. So only two combinations are possible. In the second example, the candidate is 235 and our target is 8. So which of the sum of candidates would give us 8? I think it's gonna be 5 and 3, or 2, 2, 2, 2, like 4 times 2, and then 3, 3, 2. So 3 combinations are possible. In the third example, candidate has just one number called 2 and target is 1, but it cannot be summed up to 1, so that is why we return an empty array, empty list. So this definition of combination sum takes in a list called candidates and a target integer int. So we are given candidates, which is a list of distinct positive integers, and we are also given target, an integer called target, which is a number we want to reach. Our goal is to find all unique combinations of numbers such that all the numbers add up to target. We can use the same number multiple times, and order doesn't matter. One brute force approach that I can think of is trying all possible sequences of numbers and checking if they sum up to target, and check which one sums up to target. But this will be like not efficient because there is like repeated work of checking each and every number, which is exponential, and there can also be too many possibilities. and there can be duplicates as well. So an optimal approach will be use DFS or backtracking, because in DFS we can build combinations incrementally one by one. At each step we will choose a candidate and then reduce the remaining target. We will use an index called start to avoid duplicates, and can also reuse the same number. In the end, if the remaining target finally, after subtracting it, if it becomes 0, then we can say that it's a valid combination. So, however, if the remaining target is less than 0, then we can stop exploring this particular path. So first let me import the library. So I'm gonna do from typing import list. This combination sum will basically is taking a list of candidates and a target integer. We should create a list which will store all valid combination. So I'm gonna name it result. I'm gonna create a DFS function or backtracking function, helper function. I'm gonna name it DFS. So def DFS, also def backtrack. I'm gonna say it's gonna take a start integer, a path in the form of a list of data type int, and the balance which can be remaining, which is also an integer. So here start is basically our index in candidate list from where we can choose number. The path will be current combination being built. The remaining integer will be remaining sum to reach target. Let's think about the base case first. So base case 1 could be if our final remaining sum is 0. This means that we found a valid combination. So I'm gonna say if remaining equal to 0, I'm gonna append append a copy of the path, then return nothing. Return. However, if this is not the case, and there can be another base case, which is if remaining sum is less than 0, then we can say this path is invalid. So I'm gonna say if remaining is less than 0, then return and do nothing. I want to start like iterating from the array from the beginning, like from the first index 0. So I need to write a loop for it. So I'm gonna try each candidate starting from index start. So let's write a for loop for this. For I in range start comma length of the list. So length of candidates. Our loop starts from the starting index and goes up till length of candidates. So our current number will be the first, like as the index basically. So candidates of I. Now I'm gonna choose the current number. So I'm gonna do path dot append current underscore. I'm gonna append that number. Then I'm gonna do recursion. So I'm gonna call backtrack function again from I, start with I, send path, and I'm gonna do remaining minus current num, because we have already used this value and we don't want to reuse it again. So in the backtrack function we will start from I, send the path, and remaining will be remaining minus the current number. Also we want to pop the last thing, so we'll remove the last number to try other possibilities. So I'm gonna do path dot. In the end I want to start backtracking from start index 0 with an empty path and then a target as passed to the backtrack function. I'm gonna write backtrack 0 comma list and then path and then target. Finally we will return our result. So an walkthrough could be, for example, if our candidates consist of digits 2, 3, 6, 7 and our target is 7. So DFS exploration will begin like initially the list will be empty. Then we will add 2. So it's gonna become 2 comma 2. And then 2 comma 2 comma 2 remaining is 1. Then we will pop 2 and add 3. So it's gonna be 2, 2, 3. And similarly we'll subtract the sum. In the end, when the list becomes 7, so 7 minus 7 is remaining becomes 0. So there are two possibilities, 2, 2, 3 and 7. Talking about time complexity, I think it's gonna be exponential O of 2 to the power target. Too many combinations. This is exponential, not good. And then space complexity will be O of result. Store valid combinations. So here in this problem we are using backtracking when we need all the combinations or permutations. Constraints are manageable. We are using a start index to avoid duplicates, and if our remaining sum is 0, then we are successful. However, if remaining sum is less than 0, then we can say that a particular path is invalid. We want to always start from index start. So I'm gonna submit this solution.
Got it this time.
That was a little aggressive.
Well, I got it this time.
Can I have
That was
the
a quick-
keys?
That was a quick social club meeting.
Yeah.
No.
What'd you even do?
We talked.
Yeah.
It's about what?
Your mom.
Which one's your apartment? Okay. Thank you. And then you're stranded. Just kidding, I wouldn't do that. Thank you.
How are you going to get in the building?
I'm coming back to drop them off. We have a meeting for machine learning.
For the projects that your professor did not like.
Oh, he said we need to make it.
Which one is the key again? This one?
4. The one that was
Okay.
4.
Yeah, but his roommate might be in there and I'll be like, well, okay. Okay. Bye.
Oh, thanks. Go ahead.
You-
Okay, so this is problem number 52 called n queens 2. N queens is basically something related to chess, and this is like a puzzle in which we have a problem of placing n queens on an n cross n chessboard such that no two queens attack each other. So if we are given an integer n, we want to return the number of distinct solutions to the n queens puzzle. If n equal to 4, then output is 2 because there are two distinct solutions to the 4 queens puzzle. Okay, need to look at the rules once. So we are given a n cross n chessboard. We need to place n queens, which is like one per row, and no two queens can attack each other. So they cannot be either in the same column or same diagonal, because otherwise they will attack each other. So queen cannot be in the same column or same diagonal. Our goal is to return the total number of valid arrangements. The brute force approach would be to try all possible placements in the chessboard, which is like n square possibilities, and this can be like too slow, so we can use backtracking. What if we place one queen per row, and for each row we will try all the columns. Also, we need to track which columns and diagonals are like already occupied. Which columns and diagonals are already occupied. So suppose if a position is unsafe and it has queen, a diagonal or a column has a queen in it, we will skip that thing. We can use 3 sets or hash maps. One could be a column set, which will give us the columns already consisting of a queen. Another could be a diagonal one set, which consists of main diagonals in row or column. Another set could be diagonal 2, which can be anti-diagonals from other direction, I think. So if any of these 3 sets or hash map consists or has queen, if we have this position, then queen can be attacked. If any of these sets already contain the position, then queen can be attacked. So this total n queens is taking an integer n. We need to count the number of valid solutions. So let's put count equal to 0. Now we will make 3 hash maps or sets to track columns and diagonals. Attacked ones track attacked columns and diagonals. So I'm gonna write calls equal to set function, and this calls will be columns where queens are placed. Next set could be diag1, which is the main diagonals. Main diagonals, row minus column. There is another set called diagonal 2, which can be anti-diagonals, row plus column. Now let's write backtracking function. So this will be definition backtrack, which is gonna take a row in the form of integer, non-local count. Let's write the base case. So the base case will be, what if we place all queens in all rows? So if in all rows we get queens, we found a valid solution. So we can write if row equal to n, then we can increment our count and then return nothing. However, if we try placing queen in column instead of rows, like in every column of the current row, so we can iterate through the columns. So for column in range of n, we can check if column or diagonals are already occupied or not. So if column in columns or row minus column, which is diagonal in diagram, or row plus column in diag 2, we can continue because this is not safe. Let's skip this position. Now we need a way to place the queen. So I'll place the queen. Columns dot add column. Then in the diagonal one, we will add row minus column. The diagonal 2, we can add row plus column. After this, we can move to the next row to check in that row. So again calling backtrack function, but incrementing the row this time. Then we will remove the queen. Diagonal 1 dot remove row minus column. And then finally at the end we can start backtracking from the first row. So backtrack of first row, which is 0, and then we return the count. If our n is 4, then queen can be here, 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 and here, but not in any diagonal or any column. And similarly, also n queen. So these are two possible combinations. Okay, let's think about time and space complexity. So for time complexity, I think for the worst case, as we have like n number of rows, so it's gonna be n factorial checking each row. So row 0 has n choices and row 1 has n minus 1 choices. So similarly, it is like O of n factorial, and then space complexity because of recursion stack, it's O of 1, no, O of n. And for sets or hash maps, it is O of n. So the total becomes O of 1, O of n. Some things that I noticed is we are placing one queen per row. We are using sets. And then the main diagonal is always row minus column. Anti-diagonal is row plus column. I didn't know Leetcode had ads too. I'm seeing Google ads in it. To remove ads, we need to upgrade to ad free. So if you're a free member, you get ads. I'm a free member right now. I don't have premium.
How'd it go?
Fine.
Was he there?
Yeah. I think his girlfriend was there too.
In the kitchen?
No.
Where's the kitchen?
Yeah.
Was it a mess? Did they cook?
I don't know. I didn't.
Did it look like was the stove?
I think I talked to Lauren. I will after when we sit down here. I'm gonna sit here and do my test.
Oh, okay.
Because my job.
We'll use one of these computers.
Yes. Thank you.
Yeah, of course.
How's your day going?
Good.
2 hours. What?
Yeah. Just did 18 pages in minutes. I did just today. I did all of these.
$48.
Not 48. I like this is the entire. This is the entire course so far. But I added some of these too. All latex. You still using Dia? It's almost been a week. What do you think? Weekend? You gonna continue with it, or are you gonna call it? You gonna say Buenos noches? Get it?
You were dying to say that one.
Instead of Dia like day, it's gonna be good night. What do you think?
Who's the Spanish one here?
Me? Does it mean Buenos noches or Buenos dias?
First of all, centuries.
Okay. What do you think?
What else centuries?
You're not gonna use it?
No, I am.
Oh. Do you actually like it? Yeah. You getting more used to it?
Yeah.
This one time. Do you use the video player?
No, not really.
Like when it's on another tab?
No.
It's okay. Do you use any of the AI stuff?
No.
Okay. But you use like the Google search though, right?
Yeah.
Okay.
Okay. So this is question number 22 called generate parentheses. We are given in pairs of parentheses and we need to write a function to generate all combinations of well-formed parentheses. So if our input is n equal to 3, then our output would be combination of 3 parentheses which is well-formed. Our input is n equal to 1, then output should be 1 as well. Let's write down what we know. Basically, to build well-formed parentheses,
Can I say hi to your teammates?
we can add, if we still have some left to place, we can add this character in the left.
With Marco's pizza.
Or we can add this parenthesis.
For what? Oh yeah.
If it won't make string
Torn out.
invalid.
For
Closed parenthesis can never exceed the opening ones.
I guarantee she's gonna be like, well, if you're gonna go to the gym every week, it's I guarantee she's gonna
Solution could be to use backtracking. So I'm gonna create a function called backtrack.
I'm gonna
First need something to store the result. So create a list to store results. I'm gonna name it result.
I don't know, I kind of felt better after doing it.
I told you.
So I'll create a function called backtrack. So if backtrack,
Okay.
That way I can still walk, but it's not cold.
and this is gonna take something called open count in the form of integer, then close count, which will be close parenthesis count in the form of integer as well, and then a path
And then I become like half man, half baby.
in the form of a string. So if the current path is complete, which is it's 2 to the power n, then we'll append it, I think. End of path equal to 2, like twice of the number. Result dot append path, then return nothing. Otherwise we'll add this parentheses character if we have some left. If open underscore count is less than n, then call the backtrack function.
It's 7 o'clock.
Increment the index. You can add another character as well.
Hey guys, what's up?
Only if it keeps the string valid. So
Good.
if close underscore count is pen underscore count, call the backtrack function again.
Pull up the yeah, we're probably gonna have to change this because during that was one thing I wanted to talk about. During the present, like, well, you all heard him, like, it's like interesting, but he said it's not like
Start with no parentheses placed. So initially we'll be at index 0, close count 0, no parentheses at all, and we'll return result.
yeah. So I was doing some research last night at like stuff like this that existed, and I found two like apps, and one did like you said, one like I downloaded like some images from like random movies and TV shows, and I uploaded both images, and it like immediately identified the show. And then there was another one where it was for the actor, so it identified the actor, but they didn't do both. They didn't do both. But right, but yeah, and that's what I was trying to tell him at the presentation. But I think he still wants something more. No, but I just remember him saying like go back to the drawing board and think about something like that hasn't been done, or like how you can make this more unique. So go ahead.
So this open count less than n ensures
Okay, yeah. Sorry, then I must have misheard him.
more than n opening brackets. This ensures that we don't
What do you think?
close before opening. Valid combinations deleted. So this is valid as it is complete. This is also valid. This is also valid. Then these two are valid. This is valid. This is also valid. And complexity.
Yeah.
O of C subscript
That's
N.
kind of what I got.
I don't know how to
I was a
write
little
subscript
frustrated
N, but
because,
CN, I'll write CN.
like I get the whole
Just
packaging and
catalog
stuff, but like at the same time, like I feel like the point of this project is less about creating something that's never been done and more about learning actual like machine learning concepts.
All valid
So I was a
answer.
little disappointed. When he was pushing like you need a sponsor, you need an internal sponsor, and this has to be something that's needed. Like that's good and all, but I don't know for an intro to machine learning class
Recursion depth.
where we don't really know how to do anything. Like I think that was a little much with the sponsor thing. Maybe that was just me. Well, that's the other thing. That yeah, because like I stay after for the other class, and there's like a few other groups staying, and they were like, so we can have an internal sponsor if he thinks it's fun enough, but if it's not, then we need an external sponsor. So like it's kind of ambiguous of like, do we need a sponsor? I don't think we need a sponsor because like we find it useful. Right. Mm-hmm. Yeah. Was it the game one? Okay, that's the group that stayed after. Mm-hmm. Right. Yeah, but they didn't have a sponsor. I mean, who would their sponsor be for that one? You know, that's just a fun. Yeah, that's true. So I'm not too worried about the sponsor thing, though. I don't know who the hell would sponsor our thing. Like the other groups, like the first group that presented that, like, to be honest, I don't really know exactly what their project was, but like you could tell they were working with like a teacher. Mm-hmm. And then there was the, oh, go ahead, Ivy. I was going to say there was that other group too that was doing the movie thing, but they were doing more of a recommendation. But he didn't pound on them about the uniqueness, like, because that's definitely been done before. Like every streaming service has a recommendation model. Yeah. Mm-hmm. It did sound ambiguous. Mm-hmm. What's your vibe? What's your style? Like, yeah. Right. He's like, yeah. He's like, well, he's like, I would suggest you to try to build a model, but like, you don't have to. So, I don't know. It was just like he was just kind of inconsistent again with his feedback. So that's why I was confused. I'm like, what do we really like? I feel like the requirements are loose, and that could be a good thing because it means more freedom. But also, like, you do need some guardrails in place so you kind of have an idea of what you're doing is compatible with the course requirements. So. Mm-hmm. Mm-hmm. And he greenlit it then. He was like, yeah, like you could do that. You might have some trouble, but. Yeah, so I guess we just kind of have to hound our like unique aspect of it, which I guess we kind of already identified. Like we do both, the actors and scene and distribution. Mm-hmm. 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 Okay, that sounds interesting. Mm-hmm. So you just feed the model your photos? Okay. Oh, does it actually? Oh, such as age, gender classification, attribute analysis is what's called. Yeah, that makes sense. Okay, this is pretty. It really comes with like high-level tools out of the box, like just like very simple to use. And then the age, like I'm looking at the example of this one, like age 31, emotion, dominant emotion, gender, release, probability. Um, yeah. So you're saying by feeding that all of our images into this, what's the end goal? Like we use this as a model, or we can use it to train our own model. That's kind of what I was thinking, because this like, it's nice that this does a lot of the work, but how much is it taking away from what we could be doing, like as intro, as an intro class? Because if all you cared about was just building a project that did what we want to do 100%, this seems like a great tool. But I know you put a lot of emphasis on, like, don't worry about the end product as much as learning about the model or worrying about the model itself. To me, that makes it seem like he wants us to at least attempt to build our own model, even if it's not as accurate as obviously enterprise ones out there. Stuff like this. What do you guys think? Mm-hmm. Oh, 100%. Yeah. Mm-hmm. This is like a good backup. Like, this is a really good backup. If like ours fails, we could. The only thing, this one doesn't identify. This doesn't spit out a name, does it? Mm-hmm. face recognition, the task refers to finding a face in an image database. Performing face recognition requires running face verification many times. Okay, so you can kind of like, I guess you can kind of custom train it in a way, but
So this is problem 87 called 79 called word search. We are given an M% grid of characters board and a starting word. We need to return true if
So-
the word
so you're saying for every pair of images,
exists in the
verify
grid.
if it's
So the word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. So, for example, if our input board is ABCE, SFCS, ADEE, and the word given to us is ABCCED, and this is a combination, and we return true. However, in
Right.
example 3, we can see no word could be formed from letters A, B, C, B because there is no extra B here.
opens. At the end it says it has a GitHub repo, so I assume it's the same source.
So, mm, this is the definition called exist, which takes the elements of the board in the form of list and a word in the form of string. So we are given a
I just
2D
did the math. So if we're gonna say if we have like 400,000
grid of characters
every
and
two would
word,
be like 70 billion
we need to check whether
like
the
checks.
word
So
can be formed by moving up, down,
for the same actor. Okay.
left or right,
Okay.
using each cell at most once.
Yeah.
The brute
Okay. Yeah,
force,
this is definitely promising.
the brute force idea that I can
It
think
just, I
of
think it just
is
really comes down to
starting
what you think the
from
development aspect of this.
every cell in the grid and trying all possible paths of length of word. And then we can also track visited cells to avoid reuse. But this brute force is like exploring every possible path and is
Yeah, that's
a
interesting.
huge repetition, I think.
Yeah. What do you guys think?
It is inefficient
Do you like? No, you're good.
as it
So, are you thinking?
revisits same state
Are you
many
guys thinking? So I'm
times.
trying to think better. Like two might be a little short. Like 2 weeks for a sprint. I'm thinking maybe like 4 weeks for a sprint for that. Just because the model is like the engine, the rest is just kind of. I don't think it's as valid. Or as time consuming. So I don't know. Right.
It's gonna be
So
too
I don't know if
slow
like a 4 weeks
for
sprint with all this
larger
just kinda
inputs.
like giving it 100%, just trying this, or if we could do the 3-1 approach. I'm leaning more towards the sprint aspect of it because I think it'd be good if we were all involved and like we all succeeded or failed together.
An
For everyone to learn.
optimized approach could be using
Because I wouldn't want to succeed on the model, right? And the 3 of us are working on that, and then whoever's working on
depth first
the other
search
part is like
and
not only
backtracking.
does their work kind of go to the bin, but it's also like they missed out on like the model training aspect of it too. So I'm in more favor of the sprint aspect, but if you guys like the other way, then we can do that too.
So we could use a combination of depth first search and backtracking. So word must be formed in order as we are given.
Yeah, it's definitely a decision. Definitely a decision.
And we should stop exploring a path immediately when a character doesn't match.
Yeah, because of how like objectively how simple it is to call use this library or these modules. I can't see it being very difficult implementing this and making a decent product within a week or two.
We can use backtracking to reuse cells.
Right, that's a good point. Well, let's map it out. Let's map the timeline out.
We will loop through every cell in the board.
So
if the cell matches a particular word, then we can start depth first search. Then adding
okay, final course project
each step.
presentation on the week 16, so week of 428. So that gives us about 2.5 months.
Check boundaries.
Say that again. Yeah.
Make character match.
Sorry. Yeah. Sorry. Final, week before finals. Yeah. Sorry. Yeah.
And marks
that week.
cell as visited.
Yeah. So that's 2.5 months. So inclusive of this week would be 11 weeks. So UI, honestly, I'd give that a week.
Restore this cell via backtracking.
Here, let's make a Google Doc and then we can plan.
Return true if the full word is found. So let me import the library. So it's gonna be from typing import list. We have class solution, and then what we can do initially is extract the number of rows and columns. So rows comma columns, it's gonna be length of our board, and then number of columns is gonna be length of 0.
Wrong clipboard. Sorry, I was doing latex earlier. Sorry.
We create a DFS function.
You don't like latex? It's like a format engine for writing notes.
So
copy it to mine.
def DFS, which takes a number of rows in the form of integer, number of column also in the form of integer, and an index of int. This is mapped to boolean, which will return true or false. So first would be if all the characters are matched.
It's really math equations. But honestly, it's really not as bad as it looks. There's just a few commands you gotta nail down and you can do anything. Overleaf. It's called Overleaf. It's just an online LaTeX editor. So I do that and then I copy the LaTeX to just my local system, just as a backup in case Overleaf gives me a growth. And then I lose all my Anyway. It's wait, I can send you my machine learning notes real quick. It's just I like notes to look good, and the way I was doing on the board did not look good.
So if all the characters are matched, we
So
can say if index is equal to length of word, then we can return true. This means all the characters are
yes,
matched.
some people told me about that. That looks kind of cool.
If it's out of bounds or mismatch, so if
Yeah, Obsidian. Yeah, Markdown's really nice too. Yeah, I sent the PDF. Like, this is what my. Oh, I put the wrong professor name. But it's just like code snippets and like text and headers and stuff. And then you can organize it by section. So I just do my lecture.
so if row is less than 0 or row is greater than equal to of rows,
Okay, anyway.
just in the bounds,
Back to the project. So I'm thinking we could do
or
like a timeline.
column is less than 0 or column is less than equal to columns, or board of row or column is not equal to word index.
Yeah, this is up to date. I updated.
So then in this case we return false. Otherwise we
Yeah,
mark
I told someone else about latex too, and they're like, I'm gonna check that out. So I feel like
as
starting a little bit
visited.
of a movement.
So we can make a temporary variable of like temporarily we can
That's fair.
temporarily
And like for me, like I used to be big into note taking, but like I can type about 3.5 times faster.
change the value so that it
So like just efficient, just productivity.
cannot be reused in the same path. So I'm gonna make temp of
we can just assume
column.
the bases.
Then I'm gonna make a placeholder for it. So this is, I'm gonna put a hash. Now I need to explore all 4 directions. That is going up, down, left and right.
Yeah.
So how I'm gonna write this?
Yeah, someone told me about that. I kind of might check that out. I just really like overleaves, so. Okay, so before we do the timeline, before we do the timeline, I need to pretend we kind of what route we're going to take this project. Yeah, you can like web UI and finishing touches. But Yeah, I mean, I'm game for either. Again, like I mentioned at the beginning of kind of getting sturdy with like a script.
I'm gonna make a variable called found,
Trying to do it ourselves,
which will hold all the direction.
especially after like the class, like the end example you went over.
So,
I feel like a lot more
calling
comfortable
DFS
with it.
again.
Like,
This is gonna call row plus 1,
and
comma,
kind of those
column,
libraries.
then index plus
Working
1,
with data.
which is
But
or
I think he did a good.
move down.
I think he did a good demonstration of like a basic model with the housing data. Obviously, ours is more complex, but like it got me a little comfortable with that. For me, you can't really do, well, it depends on the label is, but you can't really do median.
Row, comma, column, minus 1, comma, index.
Yeah, which is fine. I mean, there's no, it
Plus 1.
just depends on the data, you know.
Move left.
So, okay, so let's get this project idea. So,
And then we can backtrack, which is like restore the original value of this cell so it can be used for other paths.
my cursor just,
So board of row and column would be temp.
can type like normally, like normal text in size 11, so I just form or do the copy format.
Then finally we
Oh,
can
here we go.
return whether we found a valid path or not.
Oh, that's why. Okay. Yeah. Okay.
So this can be returned
So-
found.
Idea-wise, it seems like we're good with sticking kind of with our like original idea of image short clip like in actor and movie. Or, what's a phrase for like a movie or a show? Media.
Next we can try starting
Film.
the DFS
Film.
from very first cell in the grid. So I'm gonna write a loop for R in range of rows and then for C in range of columns.
I like that.
I want to start searching for the word from row and column.
Screen production.
So it's gonna be if DFS row column comma 0.
Okay. So image short clip in
Then
actor
return true.
or actor images. Screen
If
production
word found,
distribution.
return true.
Right. Yeah, some of them do.
This will return false if no starting position leads to the word. Return false.
3. distribution. So
Okay.
being confident
Try and submit it.
choice
Syntax error.
that maybe
Expected this.
like full text.
Mhm.
Yeah, you can. Yeah. So are we good with this then?
Here I'm declaring RC, but I'm using row.
So we don't
I'm gonna change it.
change the direction. I don't. Again, I don't.
Then this can be C. Here also C.
I think it's.
Can be row. And then column.
If he said if. Yeah. And if we lose a few points, so be it.
And here also it's gonna be, I think, R and then C. C. I'm making a miss. Submit again.
I think if we came back then we hold on. Well, there are
Name row is
similar
not
middle
defined.
to
Yeah,
X,
same
Y, and
error.
Z. Maybe he would be more like, oh, okay. Because there isn't anything.
This is gonna be
in my
R.
20 minutes of research last night.
C.
There was not anything that did like both of these. Maybe I'll do a little more research. I like don't think. So we'll just assume this is. Yeah.
Name row is not defined.
Right. Yeah. Even if there is, we can just say no. There's not. Yeah. So. And whatever, even if it's not as unique as the Pokemon, I guess. So
Okay.
we like it.
Let's
That's
think
better.
about time and space complexity. Think time complexity could be O M cross N cross 4 to the power L Y.
Yeah, but even
So-
I'm sure something like that probably exists.
M cross
Like
N.
maybe not as in depth as they want, but again, like a lot of these ideas, like it's hard to come up with an idea that no one's
Possible.
really done before.
Starting
On
cells.
super niche.
4 is directions. Down, right, left.
I mean, everything's a fork of each other.
L
You
is
know,
length of each word.
like
No.
there's startups
Length
like
of-
IDE startups that integrate AI into like they fork VS Code, they put like an AI chatbot in it, and then they're raising $1 billion from YC Combinator. Like nothing unique about it. So like yeah.
The space complexity can be
So a lot of
overfilled.
like you ever heard of Google anti-gravity? Okay. But that's like a newer AI IDE, but that's for a lot of
Maximum recursion
I think
depth is
Recursive.
length of the word. So here we are not using any extra matrix or extra data structure, so I think it's gonna be constant, like O of L.
Yeah. I mean, and why not? Because it's like you have all your extensions. You don't want to switch to a new IDE and then like lose all your extensions and settings. Like it makes sense. But
I'm
the
gonna
point is
submit
that
it.
they're not always unique. It's like you take a baseline IDE like VS Code and then you sprinkle a new feature into it, like which in most cases is an AI agent or like an AI, like their own models into it. So it's like yeah, that's a whole other yeah. Oh yeah, they all do. Even under the hood, even if you don't realize you're using it, you're probably using it. Yeah, because it's
So
just a
in this problem, basically, depth first
it's like a
search,
buzzword.
the
Like,
function
you know, if you
DFS
have AI, then investors are happy.
explores all possible paths recursively. Cells are like temporarily marked, visited, hashed, and restored for backtracking.
And it's like, what does that even mean?
And we start from every cell, and the word could begin from anywhere.
Well, they have TPUs too, like what's it called? Yeah. Oh, tensor processing unit. Tensor processing unit. Yeah. Mm-hmm. Right. Yeah, we can do that. We have our presentation for this next Tuesday. So is it like a technical overview of it? Right. We can keep it in this doc. Maybe it's easier to make a table. So should we include both though? The announcement on Brightspace. I mean, do you mean like functional, non-functional for both, like nice to have and must have? Okay. So I'm looking. It says please include both must have and nice to have. So I agree with that. We have must have and then nice to have and then yeah. Here, let's just do.
Okay, moving on to the next problem. This is problem number 108. Convert sorted array to binary search tree. So we are given an integer array nums where the elements are sorted in ascending order. We need to convert it to a height balanced binary search tree. So in the first example, the nums is -10, -3, 0, 5 and 9. The output should be a binary search tree starting from root node to the leaf nodes. So it's gonna be
Maybe if
0,
we need more ideas.
-3, 9, -10, null, as there is no right child of -3,
Maybe we can do that next
and
week
5.
when we actually make it.
However, 0, -10, 5, null, -3 and 9 is also
Yeah. Why don't we
accepted.
do a table structure?
So if nums is 1, 3, then output can be 3,
And then
1
for each one,
because
we can do.
they are both height balanced binary search tree. So our input is basically a sorted array nums in ascending order.
And then we could do like numbered.
Our output should be height balanced binary search tree.
Okay. You can do. Here you go.
So what does it mean for a binary tree to be height balanced?
We can do that, or just next to each bullet point, we could just put in parentheses.
It is basically difference in the height of left and right subtree. It should be less than or equal to 1
But I think we should just specify
for every node.
Okay.
So since
we can just start on the nice to have.
array is sorted, the middle element should be root.
Yeah.
To balance
I think 80%.
left and right subtree. And we can use recursion. Left half will become left subtree.
We could have some sort of latent requirement, so how long it should take to.
And right half can become
do a
right subtree.
like a prediction.
Brute force approach could be.
Maybe we could put like just an estimate, like
to take the first element as the
I don't know,
root.
because the ones I was doing yesterday, took like.
And then we
good,
insert remaining elements one by one. One by one into BST,
upper bound will be 26.
then BST insertion rules. However, with this brute force approach, it's gonna take us O n log n. Time complexity will be O of n log n on average and O of n square on inverse gauge. So in this case, result may not be height balanced.
So nice to have. That would be fun. That'd be non-functional.
an optimized approach would be to
'Cause
use
I'm looking
divide
at
and
this.
conquer.
It's under usability, ease of use. So it's not something that can be anything that can be
Fine.
directly tested
Middle
is
element
functional.
of
Anything that's
array,
more
that is root node,
so
recursively build left subtree from left half of the array, and then we recursively build right subtree from right half of the array. This will ensure that our BST is balanced.
that wouldn't be the model. It would be a pre-processing step using like a, but it's still
We import the library from typing import list.
right. And say for both. Yeah, exactly. But I think it's good that Miles put that because that's a big aspect. Yeah, let's specify. We could do both. Well, that's two different. So
Okay, so we are given a function called sorted
well,
array to
before we decide that, we
BST,
know for sure
which
actor
takes
or,
list
I
of
wouldn't even
input
say
numbers.
actor, I would say movie. Or no, we did. So we need we need the media identification and the movie identification from the API.
So we wanna convert a sorted array to a height balanced BST. Let's make a helper function
Yeah, I think like maybe search.
to build BST
I would put this as
from
separate.
nums. So this is gonna be
Squared.
starting from start and then go till n plus 1. So I'm gonna write def dfs takes an integer start, takes another integer n, and then returns a tree. So it's gonna be optional tree node.
So we can put
Then here optional. Let's
Too low
think
level.
about the base
Yeah.
case. Base case if start is greater than n, then subtree is empty. So if start is end, will return none. Otherwise, we'll find the middle index. So mid is gonna be start plus end by 2. Now we're gonna create a root node with the middle element. So I'm gonna do root equal to tree node nums and its middle. Then we can use recursion to build left half. Build left subtree from left half. So it's gonna be root dot left
into individual images.
build
It's
BS
like an array of images.
start comma mid -1. Then we can use recursion to build right subtree from right half. This is gonna be root dot right equal to build BST mid +1 comma end. Finally, we can return the root.
Mhm.
return the root of the subtree.
I see what you're saying.
So return root.
It depends how high level you want, because 3 is a solution for 2, but 3 in itself could be a requirement.
So build BST from the
I would say we
old era.
combine these, like,
So it's gonna be return
can
build
detect multiple
BST
faces.
starts with
images and
0 and
videos.
goes up till length of nums minus 1, like till the end of the array. So it's gonna be length of nums actually, and then minus 1, 0 to n minus 1.
Mhm. Yeah, that works. Yeah, that works. Find movies from it. So is this where we, for 5, we still have to query the okay, in that case, because we still have to query, so we query for actors, but we also have to query for movies that they're in. Or, yeah, sorry, TV. Yeah, what do we call it? Screen production.
It's 8 o'clock.
I'm gonna rename it to build BST.
So,
Talking about time and space complexity.
oh, well, then 5.
Time complexity can be O of n as
Does
each element
this
is
include
visited
this 4A? Does that
once you
include, like, when
create a node.
if there's multiple actors, we kind of
Then the space
align
complexity
the-
can be
that they were both in? Does that
O
include?
log of n because of the recursion stack.
So, and then 5 would just be
And here
like,
height of the
right,
recursion
exactly.
is height of
Like miles, like UI. I would say UI output distribution shows a distribution because we want to be
no extra data structures used. This guarantees like height balanced binary search tree because middle element is always chosen as the root at every recursive step.
So would these be? We can add them. There's we can add.
I'm gonna
So for
submit
this
it
one,
now.
this distribution, are these 2 different distributions, or are these going to be 1 distribution?
Okay, there is some error.
So
Okay.
right. Yeah. Well, the distribution is really the actor and then the movie in parentheses.
Then
based
I'll
on,
submit it.
because the movie is entirely dependent on what actor our model spits out.
What time does library close today? I'll go and check.
like a probability graph. Mm-hmm.
Okay, still have 1 hour to go. I thought it's gonna close at 8. But it closes at 9.
Well, another question is like, if you another question is if you upload a frame with like 10 different actors in it, which actor it's going to have to query all the actors, and how does that work when there's 10 different actors? And then say some of the actors it gets right, and then some of the actors it gets wrong. Like that's another question. So, okay, yeah. Yeah. I would say 80 is kind of high. I would say like 60 maybe. Okay, so that makes sense. I'm still a little. I think we're still a little. It's a little ambiguous exactly what the output is, though. Is there like an online whiteboard? What if we do like a whiteboard and we can kind of sketch it out? I kind of like that vision, and maybe so from when I was doing when I was working with those apps that I learned yesterday, like with the actor one, not the movie one, just the actor, every single actor that was in the scene that I uploaded, it outputted. So we could do something like that where like we display the original image of just the cropped actor in the output, and then we I'm saying we could almost do something like a distribution for each actor. And then we do one for the movie.
Alright, moving to the next question. Okay,
Well,
what
I'm
is
saying
it about?
it's almost like we run the model for each actor.
Okay, so this is problem number 148, sort list.
Yeah. So say that's the image.
Given the head of a linked list, we need to return the list after sorting it in ascending order. So, we are given a linked list 4213, and we need to output a sorted version of it, which is 1234.
Right. Exactly.
So yeah, let's do this. This is a singly linked list, I believe. So we are given
Right.
a head of linked list.
Oh, for sure. I mean, obviously, our data is a lot more
Output
expansive, which helps with the probability chart. I mean, the
head of
probability chart, like the top one, might be
sorted linked list.
like we could have a threshold where we just throw it away and we say we don't know. I say we show it anyway, but we make it clear that we're not confident. But what I was trying to say earlier is like in that scene that Ivy has up, like the green rectangle, I think that those two actors for each one,
Force approach.
like essentially the model, it only predicts based on one actor.
To
So we run the
traverse
model
the
for each
linked list
actor, and each actor spits out a distribution chart that
and
will show on
store
for each
all
actor,
the
and
node
then we
values
use
in
all
array.
that to figure out the movie.
And then we sort the array using a library, sort library, and then we reconstruct the linked list. Using sorted values. But this is gonna take a time complexity of O n log n.
Exactly. Like while you hover, you can see each person's distribution likelihood. And then at the bottom, no matter who you're hovering, it shows you
space complexity will be O of n.
Unless movies, it's harder to get a distribution chart because it's not the model. It's just
store.
So do we only show one movie, or can we show multiple movies?
In the array. This is
and that would go in the rectangle below.
Using an extra O n space and
I like
an extra
that.
data
I like
structure.
The aspect of it.
And an optimized approach could be to use merge sort.
Right.
It can be done in O1.
There could almost be like different tabs. Right. That's if like we have a solid 2 weeks left. It's like, well, let's just do the UI, I agree.
The base case could be an empty list or a single node, but in this case it's already sorted. But if not, then we can split the linked list into two halves. We can use two pointer approach,
I was saying that because we get one anyway, right?
like one slow pointer and then one fast pointer. Then we recursively sort both the halves, both the left and right half. Like not left and right, I think both the halves. And then we merge the two sorted halves. So I'm gonna import the library from typing
Well, that's a good.
optional.
Yeah. So I really do like the distribution chart because I think it's just nice to have. But you make a good point because so we have to go back to how does like when we did the 0 through 9, wasn't it like a distribution chart? Didn't it show, or was it just the bar that it thought it was? It just rose that one, and then all the other ones were like. There's got to be a way to output like multiple multiple different options. There's got to be a way to do that. Mhm. Right. Exactly. I completely agree. Okay. I think drawing that out really helped. Um, okay.
Okay, so here we have a definition of single linked list already with value and next node. And then we have a function called sort list, which takes the head in the form of list and outputs another list. So I'm going to write the base case. What if it's an empty list or a single node, then which is already sorted? So in this case, if not head or not of head dot next, then we'll just return the head itself.
Well, the UI is usability, so it could be different. Like if you say easy to use, that's non-functional. Right.
The first step could be to split the list into two halves. So we will declare two pointers. One would be like slow pointer and another will be fast pointer. Both will point to head initially.
It's almost like the non-functional is a goal. Like
And
low
then
latency, our goal is less than 20 seconds, but for 60%,
the
we can
previous
directly
will point to none,
control that.
just to disconnect.
Like this, we can directly control. Yeah, but
The
this with the
first
non-functional
half.
is like high accuracy, low latency. Like that's a goal we want to achieve.
So while we have our fast pointer and fast pointer has a next attached to it, then we can declare previous as the slow pointer and previous dot next can become slow dot next, I think.
Yeah.
Increment
so
by
UI
one.
one. So nice to have is a distribution. chart
Otherwise,
for each
previous dot
actor
next equal to
or
none.
multiple commas.
Another step could be to recursively sort both the halves, both left and right. So I can say left underscore halved,
Say 5 or 10.
left underscore sorted equal to self dot
With confidence values.
sort list. Head. And then right underscore
And then we could like maybe
sorted equal to self
hover
dot
over
list.
actor. Or I guess that could be a separate one because like we can have the hover over actor, but it might not be a distribution.
And then we merge the two sorted lists, sorted halves. So we're gonna return self dot merge.
I would be a little more specific than that.
Left underscore sorted, comma, right underscore sorted.
Oh yeah, sorry. So we can have
Create a merge function. It's gonna be definition of merge to linked list. The dummy pointer points to the initial element of the linked list, like initial node.
yeah, that's
If L1 dot value is less than L2 dot value, then increment the tail.
I don't know if that's the right metric because if it's a less known actor, but it's the only one, it still might take longer. Oh yeah, we can tell them like we detected multiple faces. Like give us, you know. What Miles said was interesting because like you could have like that courtroom scene where like you have the jury in the background and it's like you don't really care about them, but like you have the like the main defendant or like the lawyer who's actually like important to the story like in the front, and you really kind of just want to focus on them, but the model would do everyone. So you almost want to see like it's almost like if there's a way to get like the dominant people of that scene and not like that, like it. I don't know how you would do that. That'd be one, but like also maybe center, like the center of the screen too. Like the more center they are, probably the more like
Else tail dot next points to the list.
right. It's not, yeah. Yeah, I say for now we just
Yeah.
We just do the threshold for each actor because like on the jury, for example, all of those would be so low we wouldn't even consider them, and we would only consider the person who's like the lawyer or whatever, like more prominent in the scene. So we would base the movie off of only that person anyway. it would just, the only benefit of doing like dropping the background characters would be reducing latency by not doing checks we don't even need. But that's just doesn't make sense.
So here we are merging nodes from 11 and L2 in sorted order. We are continuing as long as both lists have nodes. We compare
Well, that's just a function of not overfitting it.
the
The model.
current node values from L1 and L2. Then we attach the smaller node L1 to the merged list. Move to the next node in L1.
That's a good point.
Attach.
Well, I would say, so we could do like two things with that. Like if they upload a video, we could say, hey, it has to be less than like 3 or 5 seconds, or else it's just like we don't accept it. Or
to
the better one.
Next node in L2.
I would prefer both because they're really the same problem. The only thing with the video is, depending on how long it is, you just might have more faces, right? Right. But I 100% guarantee there's a library that'll like do like 10 frames a second, and then for each frame it'll crop out, right? Like I can't imagine it'd be that difficult.
After this, we can append the remaining nodes.
Oh, that's a good point. Like, how do you like these are this? I see what you're. Well, we could use the that library that the one he was showing where it's like, are these the same people? But that would be so much latency. So it would have to do that check. Unless we, yeah.
So basically our solution consists of 3 steps. First is splitting the list, wherein we are using slow and fast pointers to find the middle, and then previous disconnects the first half from the second half. We are also using recursion, which means sorting both halves independently. Then finally we are merging. Merge to sorted linked list using a dummy node. As far as time complexity is there, I think it's gonna take us O of n log n.
Well, are we gonna put that? So are we saying the nice to have is still the video?
Each split divides the list in half.
Okay, so guaranteed work there is a video.
So log n levels.
Okay.
And then when it comes to I think merge, then it's gonna be O of n per level. As far as the space complexity
Okay, so
goes,
that's kind of up in the air. Why don't we bold that one?
O log of n recursion
So what's the
step
definition of a longer video? Like 30 seconds?
to divide and conquer.
Ooh.
28.
Yeah, that's actually a good idea, because if you're scrolling on YouTube and you want to quickly find it, you don't want to have to download the video. You just want to put the link in. But then, what if there's only a specific part of that video? Like, there's so many what ifs. Or you specify the time, like the time frame, like the time range in the video. But this is just like, I don't want to layer more and more, like expand the scope.
I'm gonna
Yeah,
try and
parse video
submit
from-
it. Where syntax error.
Okay. Yeah, we can look at this. It would be, I think it'd be functional, because we can directly control that. Okay, let's add some non-function, like let's add a few non-functionals to the the must-have. These are all functional. Like must-have, like what's like secure. Okay, we don't really have to worry about security, because usability like must be like user only. That's still functional, but it's like a discrete number. Like we can directly influence that.
Mm,
Yeah, that's a good point.
sorting both halves
Let's see. Yes.
and creating a definition.
What say it again? If you want X amount of actors.
Solution object has no attribute merge.
Okay, it is not functional. I'm sorry. So it's so ambiguous what the difference is between. Okay, establishing a capacity requirement is non-functional. So that's the one I'm on. Okay, so maybe we should go. Okay, because some of these might be. How the system should perform. That's so like latency and accuracy, like security, ease of like UI, ease of use. That's all how it should perform. Like it should be easy. Like it should be low latency.
Time limit exceeded. Oh shit.
Wait, one user or one actor?
I think it's because of next pointer.
Well,
Move fast, use steps.
well, concurrent user. That's just depends on like the metrics for which we host it, right? Like because the model will just be copied, or like each user session would have its own instance of a. I feel like that's a given. I feel like that's a given though, because what's the alternative? Zero. No one can use it. Like, yeah. What else does it say? Security. I don't think we have. There's really nothing in security. Usability, like, should be easy to use. Like, UI, like, program will be like should be easy to use. I feel like that's a must-have. Okay, let's.
Okay, I think I'm done for today. Solved so many problems. I'm gonna continue in the next live stream video. Thank you all for joining.
Well, I was gonna say, like, what if we do the first week timeline? Because maybe we could work on stuff throughout the week to help. That's exactly what I was thinking. Yeah, and I would say so. Like best way to design model, like model design. Kind of like a high level overview, like some of the libraries for facial recognition. Well, that essentially is using a library to build the model, right? Oh, yeah. I think I think we have enough weeks here where we could do like a 4-week sprint, or maybe even a 3-week sprint of just doing our own model and then using the deep face as like a backup. Yeah, like 1 week for training. We really have more time. Like, definitely don't like procrastinate on starting, but I'm saying if stuff doesn't work out, like it's not game over. Like we have. So that's another question. So if we're going to do that approach, assuming we're doing that approach, are we each going to go out and say like, hey, like we're just going to try this individually, or are we going to? That might be easier than just like trying to collaborate on it. That might be difficult. For parts of it, we could do individually. Oh, yeah. No, that's not a valid metric at all. It's not a valid metric. The metric is number of the number of commits is such a bad metric because I could commit every line of code I write individually, and it's like, oh, I have 1,000 commits. My project's so good. So how about this? How about 1 week we work on like sort of a template thingy, and then we each branch off, like we have our own branch and kind of work on that, and then we can merge the best of each of our things and merge that into main. So we you still have the commit history, but we're working on different branches. If you guys know how branching works in Git. Okay. I think yeah, I think that comes down to another question of, like, for the age aspect of it too, is that something we want our model to do too? Like, remember how we said multi-output? If that's like still a design, and that's maybe something we'll know after week 1 when we look into this. Like, would it be better to use the deep face for just the age metric, and then just our model would be facial recognition, or combine that into our model? So I don't think we really know that until we kind of look at the approach, the approach. Mhm. And then the course project reviews weeks. Yeah. And it's saying here that's so it's saying here that the project review is 200 points, and that's by week 6. That's a lot. I don't know what a project review means. Like a basic demo. I don't know if that's what he means, because you might not have a demo until everything's. Oh yeah. Probably. Or, I'm just thinking in the presentation, are you just going through your GitHub, or is it like, here's a basic web UI? Challenges, what's working, what's not. Okay. Maybe if we have some sort of a model, we could, the web UI would be really sloppy. We could throw like a basic demo. This is, the idea is becoming more it's becoming more real. 330. Oh shit. Let's put that here, because that's something completely different. That's kind of. When should we start working? When's the? Yeah. I'm looking right now. That would be a pain working with a different group because everyone meets for their main project at a different time. So trying to coordinate that would be such a nightmare. No, that's good, but I'm just saying.
Attention all visitors, the library has 15 minutes until we close. Again, at this time, the library has 15 minutes until we close. Please bring forward any checkouts. If you need a computer, they're available at the 24-hour lab in F113. We'll welcome you back tomorrow when we open up at 8 a.m. Thank you very much and have a pleasant evening.
I say we pick. I'm down with anything, but I say we pick our topic by March 2nd. Let's cover, or we could even do it earlier. Let's do end of next, like Thursday next week. Just give them our topic. We don't even have to start, you know. But I would say start researching before, like, or maybe during spring break.